Hey, algebra students. In this video, we're going to be talking about solving absolute value inequalities. Now, we're going to see that these problems are a little bit like absolute value problems. They're just like inequality problems, okay? So we're going to be using less than and greater than. But there's going to be some extra rules that we have to keep track of as we do these. And actually, right at the top here, here's our rules that we're going to need to keep in mind for solving absolute value inequalities. Okay, so look, there's going to be something different we need to do when a value is less than compared to when a value is greater than. It says that similar rules are going to apply for less than and equal to, greater than equal to. And I just want to point out that there is a reason why absolute value inequalities do this. Okay, I'm going to kind of give you the reasoning in just a moment. So for an inequality in the form of absolute value of a number is less than a, we've always done the absolute value is equal to. Now we're doing less than an inequality where k represents a variable expression. Okay, so we have something in here. And a is greater than 0, remember, because if a is less than 0, then there's nothing I can do with an absolute value on one side. We need to solve negative a is less than k, and k is less than a. This kind of looks like the way we would normally solve an absolute value equation. We'd say k equals negative a or k equals a. But in this case, instead of or, we use and. Okay, so for less than, we use and. We just need to make sure we have our inequality symbols in here as well. Now, why is this? What are we actually saying when we say the absolute value of a number is less than another number is less than a? Like, let's say a is 8, okay? So the absolute value of k is less than 8. Remember what the absolute value actually is. We oftentimes pragmatically think of the absolute value of a number as just changing anything negative to positive. And if it's positive, it just stays positive. But the actual thing an absolute value does is it measures the distance on the number line from 0. So what this is saying is what number has a distance from 0 less than a? If a were 8, for example, it'd be what number has an absolute value or has a distance from 0 that's less than 8? Well, anything up to positive 8 would be less than 8. But also, when we're talking about distance from 0, anything all the way down to negative 8 has a distance that's less than 8. So that's why we have this inclusive boundary that includes negative 8 and positive 8, okay? And if it's the less than sign, technically it doesn't include negative 8, but it goes all the way down to just before negative 8 and all the way up just before positive 8. Now, let's think about this one. For an inequality in the form the absolute value of k is greater than a, where k represents a variable expression, a is greater than or equal to 0, we need to solve this expression, k is less than negative a, or k is greater than a. What are we saying here? The absolute value means the distance from 0 is greater than a number. So the distance is greater than 8. Again, let's choose 8. That means that 8 won't work because it has to be greater than, not greater than or equal to, but 9 will work, 10 will work, 11 will work, or negative 9. Because the absolute value of negative 9 is 9. There's a greater distance from 0 than 8, negative 10, negative 11, okay? So when I have a greater than symbol, it's going to diverge, and I'm going to need to use an or statement. K is less than negative a, or k is greater than a. And then similar rules apply if I have greater than or equal to signs. Okay, so let's try this out. We're going to see that the first ones are pretty simple. We're going to get into some that are a little more complicated. We're going to have to watch out for ones that are all real numbers for an answer or no solution for an answer. Let's start with letter A. Solve and graph the inequality. The absolute value of x is less than 12. Now, we're not going to graph these. I know you guys know how to. We've done so much graphing of these. I'm not concerned that you can graph conjunctions and disjunctions with inequalities. But we do need to figure out how to apply this to actually solve the inequality. So what this one is going to be, it's less than. That means it's going to be and. A less than value turns into an and. So it's going to be negative 12 is less than x which is less than positive 12. Okay. And actually, this one was finished in one step. I got rid of the absolute value sign, and I'm finished and ready to move on to letter B. In letter B, we have x, the absolute value of x is greater than 19. Well, this one is going to be one of those divergent ones. So negative 19 is greater than x, or x is less than 19. Let's see. I could if I wanted to. Let me just make sure we did this right. So k, my number, negative 19, is less than x, or, I mixed these up because x has to be greater than 19. It didn't feel right. So let me just flip these around. 19 is the lowest number that I could consider in this expression. It's remember, 19 won't work, but anything above 19 will. And that means that I'm going to shade from 19 on to infinity here. 19 has to be less than x. Okay, so you have to make sure you follow the pattern here. Letter C, solve and graph the inequality. The absolute value of x plus 2.8 is less than or equal to 10.4. So let's go ahead and just write this out. The absolute value of x plus 2.8 is less than or equal to, that's a symbol I need to grab here. So we're going to insert, we're going to choose a special character. And actually, if you do this in drawings, it lets you just draw the character you're looking for. There we go. It's less than or equal to 10.4. Now, this is like an equation, and for now, I can treat this the same as I would do an equation. I'm going to subtract 2.8 from both sides of my inequality. That is a valid thing for me to do as long as I'm doing the same thing to both sides. Okay, so this is going to give me the absolute value of x is less than or equal to, and let's see, 10.4 minus 2.8 is, let's see, it's going to be 9.6 minus 2, 7.6. Okay, now I'm ready to solve this. It's a less than or equal to, so that means that it's going to be negative 7.6 is less than or equal to x, and x is less than or equal to positive 7.6. Let's just make sure I did these first three problems correctly. Boom, there we go. Let me just double check this one. I wrote my x on the other side. That's why my sign is flipped. I could have written x is less than negative 19 or x is greater than 19. Either way works. Let's move on to letter D. Okay, in letter D, we need to solve and graph the inequality. Okay, watch this. So I have the absolute value of x over negative 5 is less than negative 1. I need to get x on a side by itself. So I'm going to multiply both sides by negative 5. When I do that, I'm going to get the absolute value of x. Let's see, I'm multiplying both sides by negative 5. That flips the sign, is greater than 5. Multiply both sides by negative 5. Absolute value of x is greater than 5. Greater than means that I'm going to do an or statement. So what it's going to be is negative k, negative, let's see, k is less than negative a. So it's going to be negative 5 is greater than, negative 5 is greater than x, or 5 is less than x. And if I were to graph this, I would see that I would put an open circle at negative 5 and shade to the left because x has to be less than negative 5, right? Negative 5 is the greatest x could be, and it can't even be negative 5, so I'd have an open circle there. And then at 5, I'd have another open circle, and then I'd shade to the right because 5 is less than whatever x is. If I wanted to, I could flip these around and put x on the other side. If I flip x to the other side, I also have to flip the inequality sign. So if it's a little easier for you to read it this way, x is less than negative 5, or x is greater than 5. That's also correct. Let's move on to letter E. Solve and graph the inequality. Well, okay, so here I have an expression inside my inequality sign, or my absolute value markers. So for my absolute value, I'm going to evaluate that right away with x minus 10 inside. And the way that's going to look, let's see, this is a less than, so it's an and. It's going to be negative 12 is less than x minus 10, which is less than positive 12. Now I'm going to add 10 to all sides. That's going to give me 2 is less than x, which is less than, see, if I add 10 to 12, I get 22. Less than 22. All right, and that's how I work that sort of problem. The next thing I'm going to do is I'm just going to check and make sure I've gotten the last couple of answers right. So let's go ahead and we'll check D here. There we go. We'll check E here. Yep, we're doing just great. Oh no, negative 2. Oh, I forgot the negative symbol because it was negative 12 plus 10 is negative 2. I just forgot to put that on there. All right, let's go to letter F. Same sort of thing, except this time I'm going to be using an or because it's greater than. So let's go ahead and enter this. It's going to be, let's see, negative 18 is less than, let me think about that for a second. Negative 18 is going to be greater than x plus 12. Or 18 is less than x plus 12. Because whatever x plus 12 is going to be, it has to be less than negative 18 or greater than 18. And it's not going to be in the middle there because it has to be further away from 0. Okay, so what I'm going to do is subtract 12 from both sides for both of these. When I subtract 12 from both sides, this first one changes to negative 30 is greater than x, or x is less than negative 30. Or, and this one becomes, let's see, if I subtract 12, 6 is less than x. Let's just make sure I did that one right. I think the signs are going to be the opposite way because they like to put the x's first. X is less than negative 30, or x is greater than 6. What I wrote is the exact same thing. All right, we'll do letter G. Letter G, solve the inequality. X, the absolute value of x plus 21 is less than or equal to 14. Let's think about that one for a second. I think I have that less. There we go. Okay, so I'm going to subtract 21 from both sides. That's going to give me the absolute value of x is less than or equal to negative 7, but now I'm in trouble. I can't evaluate this because I have a negative value on the other side of the inequality, and I can't evaluate the absolute value against a negative value. So therefore, this one's going to be no solution. There's no way for me to do this. Let's just make sure we got that right. No solution. All right, and now let's do letters H, I, and J. I'm going to put those over here. Letter H. Solve the inequality. The absolute value of x plus 33 is greater than 24. I'm going to subtract 33 from both sides right away. So the absolute value of x is greater than negative, let's see. So 33 minus 24, 24 minus 33 is going to be negative, is that negative 9? That's negative 9. All right, now let's think about this one for a second. The difference in these two is this one was the absolute value of x is less than a negative. I can't have an absolute value less than a negative number because absolute value can never be a negative number. So there's no solution for x that would make it less than negative 7. It's always going to be positive. This one, on the other hand, if I have an absolute value of a number greater than a negative, that's going to be, the answer to this one is just automatically going to be all real numbers. Okay, this one's going to be all real numbers because every absolute value is going to be positive. Therefore, every absolute value is going to be greater than a negative. So you have to watch for these where you have a negative on one side. If it's less than a negative, there's no solution. No way you can make an absolute value less than a negative number. It's always going to be positive. But an absolute value is always going to be greater than a negative number. And that's why this one is going to be all real numbers.